Hi everyone, my name is Yazid Akao. I'm talking on behalf of the full team, composed of Malik Alassan, Mike Ongbaji, Amrish Foker, and myself, Yazid. So today I will be presenting on the paper named African Nameservers Rebuilt, Characterizing DNS Authoritative Nameservers. We are presenting at EAI Africom 2020, which is online this year. Thank you. So the agenda is very simple. We'll be covering 5 points actually. So let me start. The paper we are presenting is mainly talking about DNS, which is domain name system, one of the critical or the most critical services on the internet. Without DNS, it is very hard actually for the internet to work. Why? Because DNS basically allow names to be resolved into IP addresses, which are known by the devices connected to the network. So since DNS has been invented in 1983 by Paul Moka-Petris, DNS has evolved a lot, and globally speaking, internet has evolved. One of the major I will say improvements of DNS has been mentioned in RFC 6891, which is, I will say, the successor of the initial RFC 2671, which is talking about eDNS. eDNS is an extension mechanisms to DNS in order basically to overcome the size limitation with UDP in carrying DNS messages. So why RFC 6891 has been developed mostly because we are now dealing with IPv6 and DNSX, so DNS messages are being over and over growing over the time. So this study actually revealed the current status of eDNS 0 compatibility, of Afrinic reverse DNS servers, and the 57 Africa CCTLD authoritative name servers. And of course, we did more than that. So there have been some related work before the one we have done. And yes, of course, those related work, I will say, actually covered part of what we have done in our case. Our results actually, I will say, touch a lot of aspects, a lot of domains related to the global DNS. We thought about IPv4, IPv6 distribution of the name servers, the number of name servers for each zone, how the name servers are located and distributed around the world, the zone distribution themselves by the name servers. Of course, the eDNS compliance, I would say, which is the main topic of our paper, the TCP compliance also. So let's start with the Afrinic reverse zones authoritative name servers. The methodology we used actually was very simple. The main source of data was Afrinic reverse zones file, which is publicly available on Afrinic website. We use several tools as well. We developed some scripts. We use dig tool. We also use RIP Atlas APIs, of course, Python and PostgreSQL to store all the data, and DNS Python as well. So at the right of the screen, you can see the flow chart of our work on this stuff. And the results have been quite interesting. Yes, of course, we are saying that IPv4 is very dominant in the market, but at which level? I think that we clearly see here that yes, IPv6 usage is growing, but still we are very far, and we need to go faster and faster in IPv6 deployment, mainly because actually in Africa region we are already at IPv4 phase 2 exhaustion, phase 2. So we are almost done with IPv4 addresses, and we need to go very fast in IPv6 deployment. So in terms of Afrinic reverse zone authoritative name servers, there have been a lot of data we processed, a lot of results we came up with. And some takeaways are actually that, yes, we have seen almost 10% of LEM delegation in our study. 25% of the reverse DNS Afrinic reverse DNS have no EDNS zero activated in the configuration, while almost 2.5% follow DNS flag date 2020 recommendations. So for DNS flag date 2020, there have been several recommendations, and only 2.5% of those servers really follow the full list of the recommendation, which is quite very low in terms of percentage. But almost 97% of the full list of reverse zone follow BCP 16, which is quite good because BCP 16 talk about resiliency of the services. Transition to IPv6, actually, the servers are a bit more than 30% dual stack, which is quite encouraging. We need to continue deploying IPv6 into our infrastructures. Here as well, there are some takeaways, some interesting takeaways. Almost 1/3 of the name servers are located abroad, mainly in US networks. Of course, we are talking about US networks. We are not saying that all the systems or all the authoritative servers are hosted in the United States itself, but because we are pretty sure that many servers are anycast deployed, so they could be outside of United States. Yes, something very interesting. Top 5 African countries are known to have good overall country level latency, and it was not surprised to see them as top 5 African countries hosting Afrinic reverse zones. We have South Africa, we have Nigeria, Egypt, Kenya, and Angola. Which are actually well-known countries when we talk about good connectivity in those countries and data center infrastructures, etc. Yes, we have seen some slight misalignment between several authoritative name servers. For instance, mweb.co.za, angolatelekom.com, and link.net. We have seen some discrepancy between the two authoritative name servers. So this actually called for complete alignment, because actually some zones are present in some name servers while they are not in the others, and this of course could lead into problems. So let us now jump into the second part of the presentation, which is actually talking about African CCTLDs authoritative servers. So we are talking about 57 African countries CCTLDs. The methodology here as well is pretty the same. So we use almost the same tools, dig, ripe atlas, Python, and PostgreSQL database, and DNS Python as well. So again, at the right, you can see the flow chart of EDNS compliance for African CCTLDs. So there are some interesting takeaways here as well. Some very interesting data. More than 50% of African CCTLDs authoritative name servers are dual stack, which is quite encouraging. It really means that our CCTLDs are doing well, and they should continue on the same way. There is a high resiliency that we also observed on the same CCTLDs. Majority of them are served by more than 5 authoritative name servers. So a lot of CCTLDs actually deployed a lot of resiliency to serve the zone file, which is also something that we need to highlight and encourage. Unfortunately, when it comes to EDNS compatibility, the score is very low. Only 7.5% of the 225 authoritative name servers identified are compliant. It means that we need to do a lot of awareness. Probably we are suspecting that maybe the engineers or the CCT, the registry actually are not maybe doing the updates. They are not updating the software probably, or maybe they are not aware about EDNS, and they need to add this configuration in the system. Another takeaway here as well is that 1/3 of African CCTLD's name servers are again hosted in US. Yes, the US networks, of course. But here as well, South Africa is the first hosting country in Africa. I think it's something that we all agree on. South Africa has one of the best networks in Africa in terms of infrastructure, in terms of connectivity as well. So this is not something surprising. Some authoritative name servers serve multiple CCTLDs. When you take rip.psg.com, for instance, it serves alone 7 different registries across the continent, and also fork.sth.dnsnode.net serve 5 CCTLDs, etc., etc. But something very interesting we have noticed is, we call it DNS colonialization. It was quite surprising to notice that 15 name servers, which are .fr, are authoritative for 13 African French-speaking countries. And when we talk about French-speaking countries across the continent, I think, if I'm not wrong in my data, we have 17 to 18 African French-speaking countries across the continent. So this has been something very interesting for us to highlight as well. So in terms of discussion, yes, of course, we have seen quite good data, but of course, we are doing this presentation. We did this study mainly to see what is not going well. And in terms of negative impact for the end users, of course, some timeout can come out, or in the worst case scenario, the DNS resolution may fail. Of course, the end user may not understand what is happening. Even he doesn't care about what is happening. He just wants to go on his website. He just wants to use the internet service, and he cannot actually accept that a server which is not well configured is causing him a failure. for our engineers working to make the internet work very well every day. This is a challenge, a permanent challenge. We need to be aware of this, of the latest standard. We have to deploy the latest standard. We have to make sure that our systems are running with the latest standards. So in terms of conclusion and future work, of course, this study has explored several important aspects of authoritative servers on the reverse zones of AfriLink allocated address space and authoritative servers of African CCTLDs. Sorry. Yes, several metrics indicate global good implementation of DNS standards and best practices, which is something we should encourage. Okay. However, some indicators are really alarming. Okay. For instance, the eDNS 0 deployment in African CCTLDs. So this call for a wide awareness on the one hand and corrective actions, of course, from CCTLDs managers and registry and ISPs also on the other hand, in order to contribute to a global effort to make the internet more secure and resilient. Yes, in terms of future work, we are looking for a long-term deployment of our scripts for active measurements to see how these trends will vary in terms of DNS compliance over the time, both for African CCTLDs and AfriLink reverse DNS name servers. So that's all. And in Africa, we say merci, we say danke, we say thanks, we say jerejef, we say merci beaucoup, we say shukran, we say gracias, asante, obrigado, or just a show. Thank you so much.